the yeah. So this was they similar values for all of them, but they were quite different. So I plotted these to try and see what was happening, see if I could see any structure here. It's a little bit vague, but you get an increase and a decrease in both cases. In the end, I chalked it up to optical depth effect. So the fact that these transitions are occurring at different wavelengths from each other, and the propagation of light is dependent on wavelength. I thought that was probably the way that the medium, the waves were traveling through, was affecting the wavelengths at which it received. I thought that was the explanation. This is part that I wish I would like to have gone into more, but getting into radiative transfer. I didn't know the emission absorption properties, the medium through which light was traveling through, so this was just an attempt to understand.
And we found that within this museum subclass, there are quite a few separate connected components, approximately 450 components. And it tells us that the sort of the network of financial institutes in New Zealand, the ones that are working with offshore accounts, they're not very well connected. They probably have connections further out, but within New Zealand itself, they don't really share much connections. And we found most of them are pretty small. The largest one having 450 nodes. Sorry, there was 348 distinct components, but the largest component had 450 nodes.
Right, so a component is a group of interconnected.
Yes. Yeah. And there's about 350 distinct components. And the biggest component, this one, has 450 nodes. And the next one has 90 nodes, the next one has 30 nodes, the next one has 28 nodes, and then they taper off to like 2 or 3 nodes each. So there isn't much. We also found that this is sort of like
So each factor is made up of a linear combination of all these variables with all different weights on it. So you can see that the further up here a variable falls, the more weight it has on factor 1, and further over here, the more weight it has on factor 2. So you can see that this one here, benefit 4, which I can't remember exactly which benefit that corresponds to, but Stats New Zealand maps them all out. That one's pretty much exclusively weighting on factor 2, it doesn't matter to factor 1, so that's how factor analysis works.
Just thinking about this again, there's a big difference between funding DSOL 1 and DSOL 2.
Because DSOL 1 goes into A, B and C, doesn't it?
Yeah, it's A, B and C, that's right. And also they get funding for even a lot of the materials and stuff required to do some of these things.
Yeah.
So that would increase the participation rate and lower the rate. Whereas the money